Without further ado, I'd like to introduce you to our speaker, Duncan Curtis, who's VP of Product at SummerSource. Duncan brings nearly 15 years of experience in product development, most recently acting as a product management lead for autonomous vehicle startup Zoox. In addition, during his time at Google, Curtis impacted the gaming experience of over 1 billion active daily users with his work on Google Play games. As the product leader at SummerSource, Curtis leverages his expertise in computer vision and autonomous vehicles to supercharge the SummerHub annotation platform with deeper incorporation of machine learning. This evening, Duncan will be presenting on the challenges with 3D LiDAR annotation and 3D datasets. Over to you, Duncan, if you'd like to share your screen.
Yeah, I'd love to. Thanks. Of course, now I can't find it. There we go. Perfect. Thanks very much for the introduction, Nick, and welcome, folks. All right. As Luke said, yep, I'm Duncan. I'm the VP of Product here at SummerSource, and yep, got some background in autonomous vehicles and data labeling. So I'm hopefully going to share some insights that are useful to you tonight, and then answer some of your questions at the end. So how I'm going to address this is we're going to talk about a data strategy, your data collection options, building a 3D quality rubric, and then picking an annotation partner. So let's start with creating a data strategy. So the key takeaway here is you want to match your dataset size to your development size. So you want to return results as efficiently as possible at each stage. And the real reason for this, and I kind of show here some of the data types, and I'll walk through them in a second, but the key takeaway is that early on in your development phase, you're going to change your sensor configuration many times throughout your development process. It's very highly likely. I'm yet to see an AV partner that had a sensor configuration at the very beginning that was the same when they were further along in the project. So if you picture like, hey, I could collect the perfect data set, I could create absolutely everything I need. If you collected that at the beginning and then you had it annotated, you may actually need to collect new data, that same data all over again, and go through the process again. So really try to like minimize the data set to where you're at in your development phase. So for example, if you're in the exploratory research phase at the beginning, you should consider open data sets or enriched open data sets. And I'll talk about the pros and cons of each of these types of data in a moment. Once you move into research testing, continuing on with those open data sets and enriched ones, you may start moving into some custom data collection where you collect your own data. As you move into simple driving, such as like on a test track, you will still continue through with custom data collection. And then as you start moving into like real world testing, is that you'll probably want to be adding synthetic data into your mix to gain more edge cases. And that continues on throughout your development process. An example here why I have edge case management on the end here as one of your more final stages is as you've got a setup that actually does the vast majority of core driving for you, you'll then consider, hey, how do we make this a practical product for our end consumer? And that's when you may, depending on whether you're looking at building an ADAS or say like an L2 ADAS system or an L4 system, is you may want to add elements such as parking, or you may want to build in, as you're trying to prove out your safety case, you may want to add an entirely separately developed and separate set of sensors as a backup safety system. And those generally get added later in the development process as you have more confidence in your driving system. So let's talk a little bit about how you jumpstart your ML development and the benefits, pros and cons of each of these different types of data sets. So open data sets, they're obviously fast and they're free mostly. On the downside, you're locked into that third-party sensor configuration. And at the beginning, that's probably not too much of a problem, but it'll become more of a problem for you later. Most of the data sets are relatively small. I know Lyft's level 5 data set is actually pretty comprehensive, but it's certainly not enough to solve for full autonomy. You'll also get a predefined ontology. So it's not just the sensors that you're taking, you're also going to get the ontology that that data set provider actually created. Now, those ontologies aren't often similar between open data sets, so you may actually lock into one of them. But this is going to be really important later in your development cycle as you create different different predictive models and different ways of managing different types of objects that you actually encounter. Let's take, for example, maybe in the open data set, both cars and buses are considered vehicles. But when you're in your later in your development cycle, you actually know that, well, actually buses behave slightly differently than cars do. And I want to have those labeled separately so I can detect them and I can actually then manage them in a different way. Another good example here is like emergency vehicles. While they're normal vehicles, they actually do some very different things. So moving along, and some examples here of Kitty, Coco for more 2D stuff, and then level 5. Next is this concept of enriched open data sets. This is where you might take an open data set that already exists and have it further annotated or annotated again to match your ontology. So data collection is actually quite expensive, but you could actually go ahead and take an open data set and then have it relabeled or re-annotated. This is relatively quick. It's relatively cheap. You can define the ontology and the labeling annotation instructions. You'll still be locked into the cons are that you're still locked into their sensor configuration, and there may be licensing considerations. Some open data sets may require that if you're going to use it for commercial purposes, that you may need to republish that data set, which could be a great thing for, don't forget that it can be a great thing for the online research and development and PhD community. So that might be something you want to consider from that perspective as well. Next, we move on to manual data collection. And so this is where you actually either yourselves or with a partner company, you get some sensors, you actually put them on vehicles and you get them out there driving, obviously with a human behind the wheel. This is quite expensive, as well as the fact that you're going to need to redo this for most of your sensor configuration changes. Some sensor configuration changes you may find don't require you to recollect all of your data, but for the most part, as you make pretty large sensor configuration changes, that will be the case. Some programs that are much more further along in their development you can build your system to be more robust to sensor configuration changes, but that's a much more advanced capability. Next, we move to synthetic data creation. It's relatively quick. It's cheap per hour of data to create. You can have your custom sensor configuration, as well as use this for edge case coverage. So a great example here is you don't want to be like seeing accidents or being in accidents or near misses when you're doing manual data collection. And this is a really good way to be able to model that out. It does have a relatively high setup cost. So getting a 3D getting a 3D platform actually running, as well as the scenarios that you want to be generating, is actually a fair bit of upfront work and ongoing work. Don't ever consider your synthetic data creation or simulation team's work ever done. You're going to always want more out of it. There's also the question of accuracy of data. How accurate is that 3D data to your real world data? Some good examples of this include like, do your LiDAR returns behave the same way with different materials on objects in your 3D simulation as they do in the real world? And this can be across all of your different sensors. Where there's lens flares for cameras, most 3D products have a really good or have pretty good controls for a 2D camera, but LiDAR and radar, you may need to build your own models for how reflections and data returns actually work. It's also quite hard to model human reactions in a purely synthetic world. So that's why I'm going to, so two platforms and there are obviously many others, but Kala and Unreal are good places to start here. And I'm going to show a slightly different variation on that with the final one, which is synthetic augmentation of manually collected data. So this is where you have your real world scenarios that you've collected. You then turn them into synthetic scenarios. So you actually have the human behavior already built in, and then you can vary it from there. You may want to change the scenarios or vary them slightly. And that, at least the pros of that, gets you the custom sensor configuration, edge case coverage, and you get to extrapolate from real world examples that have occurred. So this helps a bit with the human reaction, although obviously you still need to be careful as to how far you project into the future as to the accuracy that you still gain. This has the same high setup cost, but it also has the downside of the manual data collection cost. And you've still got the accuracy of data in terms of the modeling of your sensor returns. You do then have your real world sensor returns that you can compare against. So if you recreate the experiences you've seen in the real world and your model and your sensor returns, then you can more accurately review any discrepancies there and adjust your models to make them as close as possible to your tolerance levels. So that's just a few ways to jumpstart your model development. So we're going to move into creating your quality rubric for 3D LiDAR annotations. I'm going to spend a fair bit of this presentation on this area here, because once you've collected your data, getting the right annotations for your model is going to really define how far you can push your models. So step one is you want to define the limits of your system. So this is understanding like how tight do my boxes need to be? How far away do I want to actually detect things? How it really lets you figure out the limits of it. So things that you'd want to consider here is, what's my localization accuracy? Like, how well do I position myself in the real world? What's my system performance? So from detection through to processing, through to actuation of the vehicle, what's the time that it actually takes me to respond to anything? A big consideration here may also be whether you've got early or late sensor fusion, but I'll talk about that a little bit more later. You need to consider your speed in your worst case scenarios. Obviously, when defining limits, it's easiest to look at the extremities. So you want to look at, take your list of scenarios that you're trying to address and look at the worst case scenarios there to define that. You then also want to consider there it's pretty simple math to back out there, your time to collision in the worst case scenarios. And then you also want to consider the accuracy of your HD maps, like how well does it represent the real world if there's any discrepancies there. So that once you do the math there, you can calculate, okay, well, I need to be able to detect things so far away and I need them to be this level of accuracy, because let's say, for example, that you're driving at 60 kilometers per hour down quite tight streets with parked vehicles beside. How tight do those boxes and detections need to be so that you're not clipping mirrors off parked vehicles, or obviously all of the safety cases that are standard with AV development. Next, you want to define your quality scoring. And what I mean here is you want consistent scoring across your annotations. You want to try to remove while often human labeling is a core part of getting to quality and labeling, you want to try to get to as consistent a method for scoring so that if you have two people looking at it, it gets the same results. So the way you approach this is you look at each class of annotation, you define the core attributes your model requires. Is this direction of travel, how tight the box should be, how do I want to, do I need to include, what class attributes about them do I need to include? Some considerations here are how small an object is too small. Is it, a 20 centimeter by 20 centimeter by 20 centimeter? And your scenario list should be able to help you define this. And then also you want to say how far away from you is too far. So do you want a maximum size of an object across the next one is about sizing of your cuboids, for example, in 3D is often with LiDAR, if you get a vehicle that's quite far away and then comes past you, at some point during that set of frames, you'll actually have a really nice picture of the vehicle in LiDAR, and you'll have a really good idea of the full extent of it. Do you want to choose the size then, and then make sure that you extrapolate back to earlier detection frames where maybe you only get the front bumper bar? You still want that vehicle to be its full length. Or do you want to just capture the points and say that's part of this vehicle there? Some of the reasons you may want to actually choose the full extent or estimate the extent if you only get to see a small part of the vehicle is this can be very useful for later development of autonomous vehicles when you're also managing occlusions. So if you have a vehicle that drives behind a van or something coming out of a driveway and you want to understand where should I expect the rest of that vehicle to be. Next is what's the penalty for missed objects? No system is going to be 100% perfect on finding them, so you need to have an agreed upon scoring penalty for missed objects. And then also for incorrect labels. This is actually an important one. It can be very difficult when going through very, very large data sets to get the labels right perfectly every time. Lots of tools to help with it, but you need to understand what the penalty score is for a incorrect label. Now, I want to just take a second to say that each of these considerations I'm discussing you should consider for every class. Some classes may not be as important as others, or certain attributes of them may not be as important as others. So for example, when we talked about size of object, you know, I'm not aware of any vehicles that I would care about that are 20 centimeters by 20 centimeters by 20 centimeters. And you may have attributes about, say, a vehicle where you want to know turning indicator signals and things like that. That wouldn't necessarily apply to a pedestrian. Then the final consideration is when you're thinking about how you score a set of labeled data is, do you score per frame or do you score across the whole video? You know, do you have a score given to each attribute class that applies to the whole video, or is it just on each frame that you're looking at? And just to call it out again, the thing that's really important here is that a good quality rubric means that two people with the same information would score the annotation in the same way. That's what you're looking for, is reproducibility and making it consistent. I just want to include a couple of fun ones here. Hopefully these will be useful for you, is that when automating checks or working with your labelers, whether they're internal or a third party, you may have some problems if you do automatic checks, or questions may come up. So look at these two adorable puppers here. What's their direction of travel? So if I normally, annotate dogs and say, hey, I want to know which direction they're going so I can watch out if a dog looks like it's going to cross into the street. This dog here is what direction of travel is: up, down, not important, something you probably want to consider there. But what I also wanted to point out here is that visual examples can really help convey the intent of your rubric. So when you're building up your labeling instructions that accompany your quality rubric, visuals are often an extremely good way to help with that. Another part of automating quality scoring is, for consideration here, is 3D gold tasks. So gold tasks are pre-scored tasks that new annotations are compared against. So think of, you take a video and you perfectly annotate it, and then you introduce that video, piece of that video, maybe frames of that video, depending on how you're doing annotation, to your labelers. And then you actually get the results of what they do, and you compare it against your ground truth that you originally did. That allows you to run through the quality rubric that I was mentioning you should create above, and get a certain score as to where your labeler is at. This can be really good for training and getting consistency out of your partners, as well as like being able to look at your own labeling guidelines and quality rubric and seeing if you need to make any adjustments. Because don't forget, going way back in the presentation, the goal is to get quality data as fast as you can for each phase of development you're at. So if you can make annotation labeling, annotation instruction changes to get quality data faster, then that's only going to help you to achieve your goals. So areas to consider for gold task is, can you actually create a perfect task or a ground truth task by annotating manually? It's actually quite a difficult thing in there to do, and there may be some variation there. Also consider the fact that the amount of time it should take, or the amount of times you'd want to rework a single task to say, hey, we're confident that this is as near to perfect as we need it to be. If you do use synthetic solutions, so one of the advantages of using synthetic data is that you can say, hey, I perfectly know what everything is. If you're introducing that into a set of annotations that are of real world data, is that can firstly signal to your labeler, hey, this is a gold task, pay more attention. Secondly, you need to make sure that it's actually giving you, that labeling that type of data is actually representative of how they're labeling real world data. Then you need to consider, so you've got this great perfect data set, you can introduce it to your labelers, you're confident about that. How are you actually going to score variation in what the annotators give you versus what you did originally? Will you score the points contained within the cuboid? So you look at all the LiDAR points and you say, hey, these are the ones that are contained. If you contain them all perfectly, then that's a complete score, or there's a penalty for points that were missed. What about missed nearby points? So if you had, so let's say you missed a wing mirror on a vehicle, does it actually matter to you? Does it not? What if you included nearby points that aren't part of what you were trying to annotate? So if you had a 3D cuboid around a vehicle and you've got the wing mirror of another vehicle in it, or part of a pedestrian around say the back corner of a vehicle, how are you going to score that? And then tightness of cuboid is actually also a really important one here. I mentioned earlier that in some cases, or for development purposes, later development purposes, when dealing with object occlusion, you actually may want to keep the size of the cuboid you're measuring, you're annotating to the full extent of a vehicle. So how are you going to deal with that when in different frames you're only seeing, say, the front bumper bar in LiDAR? Are you going to look for the closest surface, the closest face of the cuboid and the distance to the point? So you could imagine a point cloud being in a cuboid and you want to find the closest extent. Is that one of the ways you want to do it? Are you going to do it per frame? Are you going to do it across the whole video? Lots of things to consider there. So back to making our quality rubric, you want to consider trade-offs. And I've mentioned this a little bit. If you're in the early stages of developing a solution, speed may be a higher focus as you have more limited use cases. And maybe you're only testing on closed testing grounds, such as like momentum or something like that. Define the different quality variables that can be adjusted for your model. So some examples here include, when you're earlier in development, is do you want to have a smaller ontology? It can be faster to annotate and be less error prone, which can get you data back faster and cheaper. What about your label accuracy? Is 5 centimeters okay? Is 1 centimeter okay? There's a big difference in price for getting to 1 centimeter of accuracy. And it's a lot more time to do so. So consider where you are and your system's capabilities as to whether at an earlier stage you can, maybe set a lower maximum speed threshold for your vehicle, or not tackle the hardest scenarios at this stage of development. And then label attributes. So how many additional attributes do you really need to know about each class? Do you need turning signals defined for all vehicles at this stage of development? Obviously, you're going to want them later on when you're looking for whatever cues that you can get to be an amazing L4 system, but consider where you are in your development stage. And then this one might seem a little obvious, but experiment with your labeling team, whether they're internal or external, is try out variations that are acceptable to your stage of development, and then you can optimize for speed. And remember, the goal here is to help your development program move from start to production. And so at each stage, you want to experiment with your team, what tools they have, what tools they may want to build. There's a lot of variability here. And if you just throw the instructions over the fence, you're not going to be getting the most out of your labeling team. So just something important to consider there. Then I'm just going to talk a little bit about the near infinite edge case dilemma. So as you move along that development phase and you get towards the end, at a certain point, especially for L4 development, is you're going to come across the $100 trillion question is, do you have enough edge cases to claim your solution is safe? Your data strategy needs to account for it. It's highly impractical to collect enough raw data, even if you had the number of miles, which I think it was about 10 billion miles you would need. Miles are not the same. Highway driving is not the same as dense urban driving, is not the same as suburban driving. And then you need to also consider all of the variations in weather conditions, rain, snow, all night, day, overcast, cloudy, all these different things that you're going to need to do. And so you'll need to turn to synthetic data and simulation and scenario variation to achieve your results. So it's good to understand that early in your development phase. That doesn't mean that real world data isn't a core part of your development strategy, but do know that that's going to be a big investment as you go down the line. Finally, who should annotate your data? I'm going to say something a little controversial here. Working for a data labeling platform company here, is that your goal is to get high quality data as fast as possible, and agility is king. So I've used the same development phases that I showed above, but I'm going to suggest how you should do labeling. And I actually think in those earliest stages is that for a lot of teams, it's very fast for you to you won't have a very large data set size, or you may have a pre-labeled data set size, pre-labeled data. Focus on an internal development team. You can get a few people internally, you can iterate on your instructions, learn a lot more about what your quality rubric needs to be. And I do recommend you, even if you're doing it internally, that you treat your internal labeling team with the same way you would a third party, is that you do create a quality rubric, you do create labeling instructions, and you use that as a really great learning experience. And that as you move up the development phases, that's when you may want to look at a third-party labeling partner. Reasons for this really include like the capabilities of, so internal labeling is fast, it's easy to do, it's sometimes even easier to get those resources made available to you, or have some interns help you out in those early stages. But once you want to move to having some of the more advanced tooling, you're going to need a lot more engineering resources to be able to achieve the quality you need in your platform, whether it's machine learning assisted annotation, task management. I mean, it's relatively easy when you've got a few thousand frames or a few thousand videos to make sure that your labelers do the right thing. But when you want to start having 3D gold sets, you want to be managing, terabytes of data, and you want to be getting annotation across many different workflows. You want to be able to change the priority of what is being labeled on the fly. This is when a third-party labeling partner can really help you, because we have teams dedicated to building these tools and running these processes across many different partners, and you get the advantage of that, only having to pay that amortized cost across the multiple partners. So obviously, we're a third-party labeling provider. And so I want to just talk a little bit about our automotive and 3D annotation expertise. So we have experience with all relevant players in the autonomous navigation value chain, from OEMs to AI startups, tier 1 and tier 2 suppliers, hardware companies making LiDAR sensors, the top companies in the space. We've worked with almost all of them, and we can't name customers due to confidentiality, but we're also really good at working on highly sensitive projects. So if you have one of those and you're looking for an annotation partner, please do reach out. And we can certainly help you, even if you're not at the phase, even if you're at the earlier phases of wanting to do internal labeling yourself, we can certainly help with giving some advice along the way. We've worked with 25% of the Fortune 50, and they trust SamaSource to solve their training data challenges. And that's a really good way to call it, is it's challenges. Like, data labeling is something that is a really, really core part of getting your ML models developed and out into production to provide value to you. We've seen a lot of the issues that people encounter, and we're really a partner. We're not just a service provider. We're someone who let you learn from our expertise and really help you avoid those pit traps and pitfalls along the way. But SamaSource is a little bit different than other labeling providers. We actually were founded in 2008 as a not-for-profit with the purpose of impact sourcing. We founded this concept of impact sourcing, where we believe in providing providing good, meaningful work to people, to women and marginalized youth in places where there is high levels of unemployment, like like East Africa or Southeast Asian or Southeast Asia or the Americas. We give meaningful work for these people. We train them. We give them life skills. They're full-time employees with benefits. This is, we really care about making a positive impact on the world. And so if you're considering, hey, do I want to get labeling done with this partner or with someone who's making a really big difference in the world, this is something that we're also doing. And actually in this, I'm really happy to be able to say this year we're also recognized and certified as a B Corp. We're the first AI company to actually be certified that way. And so it's a really good way for you to have impact with the work that you're going to be doing anyway. So I think I've run a little bit earlier than I was planning to do. I did see, could we start a little early, Luke, on the questions? Because I ran a little bit quick because I saw some of the questions were more around sensor fusion topics or things like that. And I wanted to make sure I had time to cover those.
Yeah, absolutely. So we got one there from Remy to start, saying, you mentioned that 3D party labeling partner might bring ML-assisted annotations. So could you just develop a little bit more on that? Sure,
yeah, great. So there's many different ways to do ML-assisted annotation. There's common ways you may have heard are pre-annotation or assisted annotation. It's basically when we develop models that actually help humans in the loop achieve the best quality at speed that we can. So some third-party labeling companies are actually trying to essentially replicate what you're trying to achieve, which is sort of real-time pre-labeling. We actually focus on working with our annotators as well as our R&D team to make sure that we're building highly efficient ML models that consider having the human in the loop to get to quality. So let me explain maybe the nuance of difference there. We truly believe that having AI plus the human is how you're going to get to the quality bar that's needed for your data. We don't want to be providing you with lower quality data that is just super cheap because we were able to just pre-annotate everything. We believe that, you know, with ML models, we can get very close and that we need those humans in the loop to actually get to that quality bar. It's also, you know, just logically speaking, if you could partner with someone who can already annotate your data at the quality you need your model to do, maybe you should just buy their model. I mean, that's just a logical fallacy that I'm still yet to see play out.
Another one that came in, so someone's asked, what about scenario generation and applications on HIL? How to compare the quality of the scenarios to real world annotations?
Yeah, so that's a really interesting one. And so once you've got your synthetic data or your mixed real world synthetic data and you're doing variations and you're running hardware in the loop, it's a really big meaty topic to look at. How do I say that this is realistic? There's different approaches, and there's, you know, there is some good data to draw upon from different ISO standards and the airline industry as well. When it comes down to it, what you're going to need to satisfy your internal company that what the results you have are valid. And the way I personally thought about it when I was in the autonomous vehicle space was I just pictured, okay, I'm going to have to explain it someday in front of a legal body somewhere. Why did I think this was safe? Personally, I believe that being able to prove with as much real world data to synthetic data that the variation is very small and is applicable is actually part of a key part there. You may also want to investigate, depending on how much your variation of your synthetic and hardware in the loop run scenarios, how much they deviate from your collected data. You may then want to also look at certifying your models for human movement and human behavior, or sorry, any agent in the world's behavior, whether it's, you know, human, bikes, you know, cars, animals, whatever it is you want you're solving for.
Sure. On that note, if you have any questions for Duncan and you're on the webinar right now, make sure to get those in. But we'll move on to some of the pre-submitted questions from before the webinar. So someone said, could you, if you could highlight some of the biggest challenges you're facing at the moment in your work?
Yeah, no, I think that's fair. It's some of the biggest challenges that we're facing is just making sure that we're working closely with our partners to give them success. A lot of our different partners are in different stages of development. And so ensuring that we have the right tools, the right processes, and the right advice that we can give at each stage, it's a big challenge. It's a logistical challenge to make sure that we're providing the level of support that we want to all of our different partners. From a technical perspective, I'd say is that getting our machine learning to apply to all of the different variations and cases that we want it to, yeah, I mean, that takes a lot of time to develop. And so we're making really great progress, but it's one of those areas where, you know, it's something that takes time.
Absolutely. Another had asked, when data labeling, how do you differentiate between objects if the resolution is really quite poor?
That's a great question. So in those cases, I would recommend, so there's a few things you can do. One is you can actually use machine learning to, or not just machine learning, but you can use common filters to clear up images. So one of the advantages of having access to the data offline is that you can spend more resources on actually clearing up data. You can also look forward and back, so you can see like, oh, can I see that object later or earlier? And then be able to be like, oh, okay, well, that blurry thing in this frame is actually this object there. I'd also mention that sensor fusion is a really good way to consider it at this stage too, because you may have a poor detection or poor sensor return, you know, whether that's from a camera or LiDAR or radar in one sensor, but looking through the other sensors at the same time or around the same time period is another common method to be able to identify the object correctly.
Brilliant. Another live question just come in. So I think they mean, how do you accelerate the production, mostly in LiDAR annotations? and how that works with kind of the cost effectiveness.
Yeah, so what we do is we work with our clients and look at their quality rubric. We do what I was suggesting at step 4, which is experiment with your labeling partner. So what we do is we've had a lot of experience labeling other people's data, and so we look at where can efficiencies be gained that we know have been true in the past, as well as experimenting on other ideas that we have. So our goal, as I said, is to be a partner. It's not just to be like, hey, you told us to do this, we go do this and everything's done. Our goal is to make active recommendations with our partners. We also have a great A/B testing framework where we can actually run data through different groups of annotators with different instructions as one example to look, or both instructions as well as different tool sets. So one of the things we sometimes also do is look at, would there be any unique technologies that we could introduce, UI changes, workflow changes, that would actually assist with a particular problem that we are maybe seeing that's more common in that particular partner's data that we haven't experienced before or is different to what we've seen in the past.
Sure. Another from Remy, he asked, how do you deal with uncertainty in the data? So for instance, cases where a human can't really decide, do you explicitly label that or do you remove it completely from the ground truth?
Yeah, so that's it's a really good question, and it depends on how you want to handle it. So let me give a couple of, I hate giving it depends answers, but it really depends on what makes sense for your model. So when I mentioned the different attributes you want, and the different labeling instructions, so there are different ways you can handle this. You could not label it and say, hey, we're not sure. I could label it and say I'm unsure, or I can actually provide different classifications of why I'm unsure. So if that, depending on where you are in your development phase, if you're looking for, say, common use cases where your sensor configuration may not be being successful, and that may just be from a, hey, I can't actually annotate this, so that thus is not a successful configuration. We could annotate that for you and provide human level reasoning as to, maybe we choose 4 or 5 common different reasons as to, maybe it's blurry, maybe it's too dark, maybe it's, whatever the particular issue is. We could annotate that for you as well. And then we could, you could choose to either put that information back into your model, or you could at least then do data analytics on, run an analysis on what are the trends we're seeing through your data in terms of those issues cropping up.
We've had another question around kind of the cost implications as well. So someone has asked, when you run sort of through the same data with many annotators, how does that affect the cost of it and the cost effectiveness of the kind of process in general?
Sure. So there's a few different methodologies there. There's one common methodology is called multiple submissions, where we see this a lot more in crowdsourcing. At SalmaSource, we have what's called a fully vertically integrated managed team, and so workforce. So they actually work for us full time. So as they gain experience on your projects or through other autonomous vehicle projects, like a large percentage of our workforce have, they actually gain those skills and apply them in the future. And so that leads you to generally an annotation format where you have trusted quality processes to be able to identify, hey, yes, these people are doing good work. And then you have sampling of those results internally for us, as well as the client may sample the data as well to confirm that scoring from the quality rubric we defined above. And then the other way, that I started mentioning was multiple submission. We see this a lot more with crowd work, and it's generally more common with, there are 2 cases where it's more common. Is in the crowd case, it's generally more common when the work is very simple, and you're just looking, or it is very, or it's very subjective, where someone's like, oh, is this good? Is this bad? What's the intent someone's trying to do here? And so that can be a good way where you have 3 or 4 different annotators annotate the exact same thing, and you compare their results. And once you get, more agreement, if you get no agreement, you can add more annotators to get to agreement. Or if you get agreement very early on, then you can say, hey, this is a good annotation. It can be used even for some of the more complex or cases where there's disagreement in those edge cases. You'd mentioned earlier that you mentioned that there was this problem with, if you couldn't identify an object, that's a case where you might want to introduce another person to take a look at that. And you could either highlight that through our system for our quality assurance team to take a look at it, which is our next our people who sample our data, or you could build that into your workflow if it's common enough so that it's actually part of the workflow where another person would actually check that same work.
Okay, brilliant. Herman had asked, can you give kind of more examples of where 3D data sets are used other than sort of the autonomous driving setting?
Yeah, no, I absolutely can. I kind of, just given my background, I tried to pick a use case that was relatively easy to explain. But we actually see 3D data sets across a range of industries. So anything that has a LiDAR in it. And for anyone who has a new iPhone, you've got LiDAR in your phone. So we actually see it across more mobile applications are starting to come out. We see it very common in AR, VR setups, where you're trying to understand what's the spatial recognition of the room. Some are doing it camera only, but we're seeing LiDAR as as LiDAR is becoming cheaper and cheaper and making its way into consumer electronic devices. That's becoming more of a common use case. We also see it in some drone and mapping applications as well. Yeah, those are the major ones we're seeing it in. And then all the variations on autonomous vehicles, such as we do see it in robotics, we do see it in agriculture for similar use cases.
Sure. One of the pre-submitted questions we had was, what are the benefits of using LiDAR over radar for remote sensing?
There's pros and cons. So each sensor, and this is why I kind of go back to autonomous vehicles, because it's a great place to show the different pros and cons of the different sensor types. The way I like to think about it is that each sensor is good at some things and bad at others. So LiDAR can be quite good at getting a shape of an object, as well as with enough points, as well as the distance away from you that vehicle is at. Radar is actually far better at getting you a general size and the velocity. The velocity is much better out of radar, and radar is also I would also mention that radar is a technology that's been around for a long time. So there's actually a lot more research and a lot more off-the-shelf parts that you can get that are more certified, and that can speed up your development in that way. Given my background was trying to solve fully autonomous driving, I would say you need both, but it depends on it depends on your use cases and your scenarios that you're trying to solve for. But that's the kind of thing that I'd be happy to talk through with the clients if they were looking for a certain solution, and we could go in depth on their use case and why a particular sensor is good or not. Also, you have to consider LiDAR, the failure cases. Radar can get poor returns if it's near a large metal object. LiDAR may not perform so well during rain or through steam. Actually, a very interesting edge case there could be to compare, say, camera versus LiDAR, is that if you think of those iconic scenes where you see the steam coming up out of the streets as it's getting into the colder months, then your LiDAR may actually say, hey, there's an object in front of me, I can't possibly move ahead there. And whereas your cameras are saying, no, we're totally clear, what are you talking about? And so you may actually need to train a model specifically for steam detection. Steam does actually have a shape and a set of attributes about it that can be identified. So you can say, hey, I can trust this for now, and maybe apply a different driving model for that particular time while you're dealing with driving through that.
Sure. Another one that kind of asked more on the data side from one of the pre-submitted questions that said, do you have any top tips for ensuring data quality, or sort of having the highest quality of data?
Yeah, so I would recommend 3D gold sets. I do think it's a really valuable resource. I would also recommend introducing something that we call auto QA. So auto QA is basically the introduction of programmatic error checking. So there are things that humans are really good at, which is why we want humans in their labeling. And there are things that computers are really good at. And those are generally two pretty different things. So if I'm, say, annotating 200 vehicles in a particular, I'm on a busy street and I'm looking out and I'm annotating a full scene, and the client has said, hey, every vehicle needs to have its own unique ID, and that ID cannot be the same as another vehicle. If I'm going through and, okay, I'm up to my 153rd vehicle, I'm like, okay, it's vehicle 152. Oh wait, it's very hard for a human to know that they have perhaps and it labeled it with the same ID as another object. And it would also be very hard to catch in sampling if another human was to look at it, to look through an entire list and to catch a single small error like that. However, you could build a rule, a programmatic rule that we can build in, that we actually do this in our hub as a standard offering, is that we can build the programmatic rules relevant to your quality rubric and your annotation instructions to check for errors like that, because a computer would just instantly, if a labeler has gone through and said, hey, this looks great, they go to hit the submit button, and we actually can do a lot of checks this way and instantly give them feedback like, hey, hold on, I see that you've annotated these exactly the same. Or another example, when I was showing the dogs laying on their back in a street, is that a common way for us to check is, do we have the direction of travel correct? Is that it is very uncommon for you to have a direction of travel that is up or down as a pedestrian or as an animal. However, we can provide a programmatic way to say, hey, check this, this doesn't seem like it's correct. And then the annotator could say, hey, no, that is correct, or let me go fix that. So those are a couple of ways. I would also say understanding your, I'm just trying to think about the other ones that I recommend to ensure high quality data. Having a really good feedback loop with your labeling partner, whether it's internal or external, is there is going to be edge cases, and making sure you build out over time that set of edge cases so that the annotators can just like say, hey, I've seen a weird thing. How do I deal with that? If you've answered that question before, making sure that's like more on a knowledge-based level can be addressed easily. And then I would say those are the key ones that really help with making sure that you hit high quality. I personally am biased because we have a managed workforce and the years of experience they've got. Keeping people consistently labeling on your project really does drive quality up over time. There's an interesting study by HiveMind with Cloud Factory, where they compared a managed workforce versus a crowd workforce, and they saw the annotation result differences. Now, I'm not saying crowd providers don't provide the same people working on it at all times, but our system is inherently built that way. So the people annotating for you stay with your project, and so that they build up that experience with your work and that quality bar.
Sure. Another question saying, can LiDAR, I know you kind of already touched on this roughly, but can LiDAR be used during bad weather conditions such as heavy rain that would cause refraction of light? Also, LiDAR uses powerful lasers. Will that potentially affect humans?
Sure. So almost all LiDAR, so let me address the latter piece first. Almost all LiDARs are eye safe. It's, no one's releasing products out on the street that does not conform with eye safety standards. That's so not really an issue there. There are maybe some more interesting issues about potential threat issues of people shining LiDAR lights or lasers back at your LiDARs. But being able to, there are methods where you can actually detect if your LiDAR is either suffering internal problems or issues from from an attack. LiDAR does have weather issues. All sensor types have strengths and weaknesses, and heavy rain is a problem. I would mention that there is also both LiDAR and radar in different ways, but in this way, LiDAR also gets reflections off different surfaces. So you get what we call a ghost image. So you might be like, there's a car. So if you look at a street, there's a car in this lane, a car in that lane, and there's a whole other car in between those two cars in the same space. Clearly, logically, something that doesn't exist, but it could be a reflection from a different sensor or from a different location. So that can occur as well. When we're talking about LiDAR and weather conditions specifically, and I recommend this as you go through your development phase, is you're going to need to build detectors into your system that say, hey, this is a condition where I can't trust this sensor, or I need to have a lower level of confidence in this particular sensor's return. And that also will play into your sensor fusion choice of whether it's early or late sensor fusion or both, and how much you trust individual sensors at a given time.
Sure. A slightly longer question here. Somebody's asked, when trying to understand a scene, switching modality can be really helpful, in brackets LiDAR slash camera, for instance, as well as going back and forward in time and going across data, in brackets again, data recorded on different days. Do you provide these kind of options for your annotators?
Yes, yeah. So sensor fusion is a capability we have, and so the idea of you're absolutely right that jumping between modalities can be really helpful, as well as projecting those annotations that you have made across those different sensors. So if you're looking at your 3D scene and you've got a bunch of cars there that are already labeled and you're trying to figure out something else, going to look at the 2D image. It's really helpful if you have those boxes actually projected across as well, because it gives you a much better orientation of like, oh, there's those 3 parked cars. Oh, okay, that's what the thing I'm looking for is. So it helps you orient yourself. There is actually an advantage in looking at the LiDAR data for a 3D perspective. But then when you go back to 2D, sometimes it's quite hard to be like, okay, but where is this? And it's really helpful if you could drop a cuboid where the object that you're not sure about is and see where that is in 2D. But yes, we offer the going back and forth in time, as well as different sensor, looking at multiple sensors for your annotation.
Okay, brilliant. Another pre-submitted question. Somebody had asked if you've seen any trends emerging recently, or if you have any predictions of potentially future trends that might be coming into this sort of scene for you.
Okay, I could either take that as autonomous vehicles in general, or as in LiDAR. I'm going to take autonomous vehicles first. The trends I'm seeing is we're starting to see the more advance of advanced like L2 systems, where we've now just recently seen the GM Tesla competitor come out. And I think we're going to see that become much more standard across auto manufacturers, as those a lot of them have their own programs and are initially trying to solve for the more Tesla solution rather than the sort of true L4 development. We still have not yet seen, despite small public trials, we've still not seen a mass deployed sort of true L4 system at speed. I think we will continue to also see more niche use cases actually starting to be deployed, whether it's slower buses or fixed routes or other things like that. That's a natural progression of how this kind of technology will roll out, but that doesn't necessarily define that L4 is like here next week.
Okay, brilliant. Herman had asked, when you say LiDARs as a standalone, would you replace cameras, or would they augment the accuracy of existing models that rely on camera feeds?
Sorry, could you just repeat that?
Sure. So Herman had said, would you say LiDARs as a standalone would replace cameras, or would they augment the accuracy of existing models that rely on camera feeds?
I definitely the latter. I mean, I've seen some very advanced LiDARs that, I mean, we're getting pretty close to it. Looks like a video. Like I can read, signs that are just, sort of, if you think of a movie theater or a shop that actually has its name written in like stenciled letters out the front or something, you can start reading that. But LiDAR doesn't return a whole load of the rich information that you get out of camera. So I think we're going to see more and more of those of the sensor fusion occurrences. And I think that that's not just for autonomous vehicles, but even when we talk about like AR, VR, or even drones or other use cases, it's the combination of sensors that really get you much more rich results, even though it is a more difficult development path.
Absolutely. Another question from somebody watching right now asked, what is the most challenging area for annotators in 3D cuboid annotations? Do you have any of your own tools for 3D annotations?
Yes, we've got our own tool for 3D annotations. You can check out summersource.com, and we've got a automotive area on that site, and that you can go check out what we do. I would say the most challenging area is fatigue. I mean, our annotators are amazing people, but they're still people. And so when you get through to your 8th hour of annotating the same scene, it can be quite difficult. There's ways to help manage that, and we do that. And then that's from a human management perspective. I would say from a technical perspective, it's generally around the very edges of annotation. So if I was to say, if we were to annotate vehicles and we wanted to annotate that same vehicle through the entire scene, relatively easy task to do. You could either pre-annotate or interpolate across frames. When you get to the very edges of what the LiDAR can pick up, and there's maybe 2 points left, you literally only have 2 dots of that vehicle, and then accurately putting it in the right place. There's challenges there with, how good is the sensor calibration when we're swapping between 2D and 3D that the client has provided us. That can be a challenge if their calibrations aren't right. So you're trying to put an entire vehicle in exactly the right place with 2 LiDAR points on the entire thing, because you see it later and you definitely know it's that vehicle. But did you 100% accurately place it there, especially when you project into 2D and there may be some variation in the sensor calibration information passed through.
Sure. We have another question saying, with Tesla's stance on LiDARs, do you think point-to-cloud annotation will stay relevant for autonomous vehicles in the next decade or so?
Yes. I think Elon and Tesla have done an amazing job building the system they have. I think Elon is probably right that we'll be able to do camera or camera radar sometime in the future. It's a long way off, and it's surprising to me that you wouldn't want to give yourselves as many tools to solve the problem as possible. Especially now, I understand when Tesla was first coming out with their vehicles that LiDARs were extremely expensive. But as we're seeing the cost of LiDARs come down as production ramps up on new types of LiDAR, greater manufacturing volumes, that LiDAR will be here to stay for a while. And then I would ask you the later question of when you potentially could solve with cameras only, as cameras improve in quality, as well as compute power becomes more available and cheaper. Why would you, if you've got your LiDAR down to roughly the same price that you're paying for cameras? I mean, don't forget it, at automotive volumes, you're talking about, a relatively decent megapixel camera is less than $10. So if you get LiDARs down into this kind of range, why would you not have it when it does things that cameras don't, and it gives you added safety? And I think it's going to be the safety element that really drives its inclusion for the future. I mean, Tesla has a really strong advantage with their offering in that it's a backup system. It's a driver assist technology. You're supposed to always be paying attention. And so there's a very big leap from that to, level 4.
Okay. Dale has asked if you have any experience with synthetic scene generation tools.
Scene generation tools? Yeah. So yes, I do. My recommendation would be it's an entire topic in and of itself. Things I would recommend looking at is how do you want to run this at scale? So it's quite easy to get started with a GTA type experience, relatively easy. Things you want to consider is how are you going to create the worlds that you want to have generated? Are they going to be randomly generated, or are you going to use specific locations? Going back to my comment earlier about fixed routes, it's quite easy to very highly accurately map out an area with, if you drive through it and you collect your LiDAR data, you can then 3D model on top of that to get an accurate world map that you're going to simulate in. But if you want to do generic random parts of worlds, and then the other areas I would consider for it is, do you have access to, or can you create your own models for sensor return types? That's the other big area there. And then how are you going to do scenario generation and take that in from a scalable perspective and say, here is my language or definition language of all the scenarios I want to run, and how am I going to ensure they get run through my simulation and look at the results in a human readable way? I realize we're at time, so sorry for a quick answer on that last one.
No, absolutely not. I will just say, for anyone that actually has a question that hasn't been answered, we've put down through quite a few questions now, make sure to connect with him on LinkedIn, and also with SamSource. Make sure you're following all the brilliant developments and everything coming, I'm sure, next year. But I do want to just close with one question that I do like to ask everybody. what are you most excited to work on next year in 2021?
I'm most excited about continuing to increase our impact. We've got some really cool technology pieces coming out that I can't talk about yet. That would be my other answer.
Sure.
Really interesting product launches that I'm super excited for. But it's the reason I joined SamaSource is being able to work on the cutting edge of AI with a great research team that are really world class and amazing, and getting to know that every day I'm like helping bring about a new way of working and helping people out of poverty who really need that help.
Sure, absolutely. With that, I just want to thank you for your time. And as I just said, make sure you're connecting with Duncan on LinkedIn. If you have any further questions, I'm sure he'd be happy to go through them there, as well as following SamaSource. But thank you for your time, Duncan.
No problem. Thanks, Luke.
Thanks.
Everyone.
Cheers.
Bye.